This lesson almost is identical to the lesson about congruence proof criteria, where we established certain guys that worked and didn't work in terms of having enough information. So let's look at these three guys in particular. First, maybe let's look at this guy. Angle is probably the most predominant reason for two triangles to be similar, or AA. Because there is no side that's physically locking anything in, we know through dilation and other experiences that we've had that if we dilate this guy or enlarge it or shrink it, that those will be proportional in their size and shape, and therefore have to be similar. So AA is very popular in this. In a similar way, if you had three sides that were proportional, this is not the side that we knew in congruence. This means that each side, this group of this ratio and this ratio and this ratio, that the ratios are equal. And ultimately what that means is that we had a triangle here, and in this case enlarged it or shrunk it, and then we get our matching one, and that the sides would be proportional. If the sides are proportional, we know that this was indeed a similar triangle. And the last one is kind of like, again, one that we did with congruence, is a side angle side. But these sides, again, are not referencing congruence, they're referencing a proportionality of the sides. So if you know an angle, the angle doesn't change. And if you know that the sides grow proportionally to each other, that would again lock in that idea of similarity. So there are three of these guys: side, angle, side, 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 and angle, 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 or just angle, angle. The predominantly most popular one that gets used is this one. It's mostly because it's very easy to find two angles, and if you have two angles as your value, and then you have a similarity scenario. Let's look at each of these three items as to their potential for similarity. So in the first case, I guess we see a certain level of information in terms of two sides and an angle that's been given. Now we notice the same angle is used. So really what we need to do is check the proportionality. This potentially could be side, angle, side proportionality. Now one of the questions that you have to ask is, how do I know if the 8 goes to the 14.4 or if the 8 goes to the 12.6? How do we know? It could be flipped and things. The higher number here is 8, and the higher number between these has to be 14.14. So that is a little clue to us that if it's going to work, and we don't know if it is, but it would have to go the largest in one to the largest in the other, or middle or small to small, and so on. So let's just do the math on that one. Let's do 8 is to 14.4, and let's do 7 is to 12.6. And if we multiply these out, when we cross multiply, which is how we would handle this kind of a question, we're testing to see if they are indeed equivalent. And sure enough, they do multiply to the same thing. So what that means is that they are indeed proportional. So we do have two sides that are proportional and an angle between them. So this is a definite yes. This is a set of similar triangles. In this case, there are no angles, so the only thing it could be is side, side, side. And we're not sure if it is, but we would have to check our ratios. So how do we know who matches who? We'll use the same criteria, that the smallest in the one would go to the smallest in the next, which is 9.1. Medium, which is 10, goes to medium, which is 13. Large, which is 12, goes to 16.2. Now you actually would need to check a couple of these connections. So let me do a little cross multiplying. So what we would be testing here is to see if this number multiplied would equal this number. And actually, in this case, it does. The two sides equal out. Now, what that's testing is that this ratio is the same as this ratio. So we need to see if the third ratio would also work out. So let's do the same thing. Let's test if 13 times 12 would equal 10 times 16.2. And we find out that 13 times 12 is 156, and that 10 times 16.2 is 162. And so this final ratio, this guy here, is not the same as the other ones, and so this is not our method. Now it could have been, but the ratios don't work, so it's not congruent or similar by side. In the third example, we get a little hasty. We see the 51, yeah, we see that, and then we see that 62 is here, but we see 67 is here. Many students will say no right away because we don't have two angles. But my warning to you, friends, is that what you might want to do is, because one of them matches, you probably need to check the other angle. When I solve for this angle, guess what number comes out? 67. And if I solve for this angle, guess what number comes out? 62. So actually, we have an angle-angle situation here, and our answer is yes, these guys would indeed be similar. Be careful with that little trick, it's a great one. Let's look at these last four. So this one is actually an easier case than the last one we did. We have both have the 42 and the 68. Immediately this is AA. You bet we're good to go. Now on the next one, we see that we have an angle that is between them in both of those positions. And so all we have to do is check the proportions. 8 is to 12 as 7 is to 12. Now immediately you can see that 8 is to 12 is not equal as 7 is to 12. So this is a no answer at this stage. On the next one, in the bottom left corner, it looks like there's nothing really given to you except parallel lines, but we learned corresponding angles would be equal, and there are some corresponding angles here as well. There's also an angle in this corner that is common in both of those. The short of the story is parallel lines always give lots of angles, so we would say it is similar by AA. Now the last one, let's do a little connecting up here. Now it's a little tricky by the way it looks as to who goes to who, but I gave you a trick here. 5 is going to go to 6. And let's see, what's our middle number? 8 is the middle here, would go to the 9.6. And then our last number would be the 9 and the 10.8. They would go together. Let's take a look at this by itself for a minute. So let's set up these ratios. It would be 5 is to 6, as 8 is to 9.6, as 9 is to 10.8. At this stage, we need to check a couple of proportions. We'd check 5 times 9.6 and 8 times 6. We would also look at that as 48 equals 48. So it's good to go. Now let's check the other one. We would multiply 8 times the 10.8, and we would multiply the 9 times the 9.6. And in both cases, when we do that, we get 86.4 in both of those cases. And so those ratios are good to go. So these are good and these are good. Then together they are all good for side proportional.